Good afternoon to everybody. My name is Dr. Timothy. Today we want to start our class, and I would like to share my screen as usual. At the same time, I think these notes have been given to you all. So I am sure all of you have this note with you, this code with you. So can you see my screen, please? If you can see my screen, let me know. Can you see my screen, please? Can you all see my screen? Okay. Can you all see my screen, please? Or mute yourself and talk to me. Can you hear me?
Yes.
Okay, good. So supervised machine learning, I want to do the regression parts. So the regression part is this. No, I try to brush it up. The machine learning is very broader than this. Try to brush it up for you. Having in mind that you must have done it before now. So the first thing is to check your working directory, like I said in my previous class. So you check it. You can use this code to check it, or you can use this code to check your working directory. So this is my working directory here. So user, then you go to your working directory and save the data like I taught you the last time. And when you save your data, the next thing you have to do is to import some libraries. I've written and prepared this library. This library has been imported. You can see it has been imported. So, and after that, the next thing is to import the data set into this place. The data is not in CSV. The data is in Excel format. It's not in CSV format. So you can see data set now is in .xlxx. So it's in Excel format, not CSV format. That's why I use read underscore Excel. Then instead of, yes, the one I taught you last time was pd.read underscore CSV because data was in CSV. But this one now is in Excel. So that's why I use read underscore Excel. So as you can see, the data sets, it has been imported into these environments. So from there, we now do some pre-processing. So this is a pre-processing start from this step one. You look at the shape data set. The shape is telling us that we have 12 columns. We have 236 rows and 12 columns. That's the shape of data sets. So after that, we look at some information about data set, info. So data is named team.info. So when you check the info, you can see these are the information for the data sets. After the next step is what? That's step 3. It will check if there are some missing value. There's some missing value. You can see we have some missing value here. 23 missing value, 23 missing value for these dates, Oscars, Okuku, Okay, M.Sc, Ofa, Ikirun, Igbara, Ifewara, Ibokun, Ejirinya, Efon, Ajase, Ipo, and so on and so forth. So with this, that shows that we have some missing value. And the next step you have to do is to look for how you can solve the problem of missing value. If you look at our data sets very well, you see the data set here, they are all continuous variable, continuous value. They are real values. You can see they are real values. There is no categorical. That's why we are using some regression. So because they are all continuous value. So after you have done the next thing is to find how will you fill the missing space. And how you can fill it is for you to find this code, team.fillNA, then team.me. So what this code is telling you is that you find the mean of the rest and use the mean value to fill the missing space. That's what the system is telling you here to do. So the next thing now is now check again. After you have filled the filling value, we check again to know if we have missing value again. Then we use the same code to check again. We can see that there's no missing value again. So all these other 23 you have seen last time here, they are already gone. That means there is no missing value any longer. So the next step now is to check for outliers. So how do you check for outliers? These are the way. You can make, there's several ways you can check for outliers. One of them is Z-score. You can use Z-score to check for outliers. And this is the code. This is the code. So check the code for the outlier, you can see. So in these data sets, you can see there is no, this also shows that there are no outliers. All values in data sets are inliers. What do you mean by inliers? Inliers means when data sets does not far from each other, that is inlier, are within the same range, that is inliers. But we say outliers when some data sets, data points are outside the normal range, outside their range, far away from each other. So that is what's called outliers. I think for my previous class, I told you outliers. So the next is to check for normality, assumption using Shapiro-Wilkie test. You know, I told you that as we move on, I will give you robust code. So this code I'm giving you now is very robust. I check for missing value, I check for outlier, I check for normality assumption. So using Shapiro-Wilkie test. Shapiro-Wilkie was developed in 1965. That's Shapiro-Wilkie. And this is the code for Shapiro-Wilkie. This is the code. So look at the interpretation. The null hypothesis of the Shapiro-Wilkie test for normality assumption says that sets are normally distributed. So since p-value, the p-value we got here is what? Look at the p-value, 1.76682 and so times 10 to the power minus 73. That means this one has written in what? In standard form. So look at this value. That means this value means that you have to write 0.00000000 up to 73 times. So that means everything there is still 0. So that's our p-value. And since our p-value is less than 1.05, we reject the null hypothesis and conclude that the data sets are not normally distributed. So data sets are normally distributed. So in that place, to overcome this, you have to go for data transformation. And there are several ways to transform data. But I just choose this Yeo-Johnson transformation method. This is the formula for Yeo-Johnson. I just give you this formula out so that by the time you want to write your own, your thesis, your exam, you'll be able to write all these things extensively for me. That's why I give you all this area. Now, properties, advantages, disadvantages, then application, and so on and so forth. So now you have to, data should be split into what? Into different components. S1, I choose S1 to be Oscos, S2 to be Okuku, S3 to be Okemesi, and so on and so forth. Then after that, I choose my Y to be what? To be dates. That's my Y to be dates. So I apply Yeo-Johnson to check for the normality. Sorry, to correct the normality, the normality assumption. So Yeo-Johnson has been done here, and has been corrected. It has corrected the normality assumption. So, and after that, we obtain this graph one by one. This is the graph when it was not normal, and the second one here is the graph when it is normal. This is the original one, and this one is for to transform data. This one is for original data. You can see the difference. You can see at the shape. The best shape shows that data has become normal. So this is another one for what? For Kuku. This is another one for Kuku. You see now, the same thing I did for different terms. I did for different variables. All those terms are different variables. They are different variables. So, and you move on until you get to now regression algorithms. I make use of 16 regression algorithms. Number 1, linear regression. Number 2, decision tree regression, elastic nets, gradient boosting, K nearest neighbor, random forest, SVM, extreme gradient boosting, ridge regression, ARD regression, Adaboost regression, bagging regression, elastic net CV regression, lasso regression, linear SVR regression, and gamma regression. So I made use of 16 regression here. So if you want to do your own too, you can use the same 16, or you can even have more than this. You can have more than this, you can do like 20 or 18, or you can use the same 16 anyway, if the regression is what you are choosing to do in your assignment or in your exam. So now I make use of 7 different evaluation metrics. I made use of R squared, I use of mean square. Somebody is stopping us with class, please. So now the next thing, I made use of about 7 evaluation metrics. So mean square error, root mean square error, mean absolute error. You can see MAE. You can see MAE. You can see mean absolute binding error, mapping. You can see also I use this one too. Now from there, I now begin to perform the machine learning algorithm. So the first thing I have to do, data set is changed to team 2. Team has got 2. They are put all this data set in the front. Then from there, I check data set now here. I've removed the words. I've removed the dates. So which is standing as what? Standing as depending on target variable. So from there, I write describe just to tell me more about the data sets. So these are the mean, standard deviation, minimum for each of these variables. These are the results. So now the next thing is target and future variable. So the target variable now is the future variable now is what? Is your X, which is this. I drop the what? The target. And also this one. So now the first one is what? Is this X, Y, which is the target. So now the next thing, I go ahead, I have linear regression. This is the code for linear regression. So, and also I wrote the code to find all those evaluation metrics. Can you now see? So this is the evaluation metrics, R square, 0.53, mean square error, 14.424, and so on and so forth, up to the what? The graph. The graph. Look at the graph. Look at the graph. So from there, I now move on to where? I move on to where you have the decision tree also. Decision tree. This is my decision tree. From there, look at the code, then look at the graph. Look at the graph. You can see elastic net regression. These are the what? These are the code. These are the code. Then look at it. Look at it. Look at it. This is a graph for elastic net. So this graph shows that there is no relationship between the actual and what predicted value. So this one here means that there's a little relationship, though not that perfect, not that good. So then you have another one here that is under gradient boosting regression. This is the code. This is the result. R square is 0.01. Mean square error is got what? 29.59, and so on and so forth. Then you have this your graph. After that, you have KNN. KNN regression is here. So after KNN, then you have this value for KNN. Then random boost, random forest regression. We make use of this code. Look at the code, then look at the results. Then SVM, look at the code, look at the results for SVM. The extreme gradient boosting, look at the code, look at the results. Then rich regression, look at the code, look at the results. Then automatic relevance determination, ARD regression. This is the code, look at the results. Then also we make use of what? Of other boost regression. Other boost regression, then bargain regression. Then you have after that you have elastic nets regression. Elastic nets, then lasso regression. Then look at the code, look at the then you have linear SVR regression. Look at the code, look at the graph. Gamma regression, which is the last one. Look at the code, look at the graph. Then summary of all the results. Look at the code I wrote for the summary of all the results. Check my code and also check the table. The table displayed. R square, mean square error, root mean square error, and so on and so forth. And these are the regression models, algorithms. So from there, from our indication, it's obvious, clear that linear regression algorithm outperforms all other algorithms. From the computation of R squared, the linear regression produced the highest value, 53%, followed by ARD, 47%, while other algorithms produce insignificant coefficients of determination R squared. The result also shows that the mean square error produced by linear regression is approximately 14, while that of the ARD is 16. From other metrics, linear regression shows that it is the best among all 16 algorithms of supervised machine learning compared. Therefore, it is recommended that linear regression should be used to model the data set. That's the end of today's class. If you have any question, interaction, please let me hear from you. What you need to do is to sit down with this code and practice it yourself. If you have any difficulty, you can get across to me so that I can explain further. Any comments? Any questions? Suggestions? I'm with you, please.
Doctor.
Yes.
This is Joseph. I want to say, when we want to find these outliers.
Okay.
No, rather, when we want to fill, when we use the FINA code, as I saw you use, in some occasions we use the mean. In some occasions we use the mean.
Okay.
As I've seen you use in this place also.
Yes.
And other occasions I've heard about mode, like the other one you used last time. So when do we know when to use mean, mode, or median, all those things?
Okay, good. If the variable in question is
I don't
continuous,
know whether my question makes a meaning.
It makes sense. It makes sense. If the variable you want to fill in is a continuous variable, like for example, now look at this variable now. Look at this now. Look at Ofa. Look at Kemesi. Look at Okuku. They are all continuous. Continuous means that 0 point something, 1 point something, 2 point something. They are continuous value. They are real value. So you make use of mean in that place. On many occasions, mean is suitable in that place. And sometimes you can use median here as well. Median is still appropriate here as well. The median is that you want to make use of median. Before you can use median, you must have seen that there is no outlier, or you have taken care of outliers. You know what you have done here, what you are doing here is to feed the missing value. So if you want to use median, you must have known that, okay, if you want to use mean, you know that there is no, that the outlier has been taken care of or will be taken care of. But in a normal situation, mean and median are recommended in this type of data sets if they are continuous like this. But if data set is categorical, like maybe like male, female, male, female, or maybe like agree, disagree, undecided, agree, disagree, undecided, that's a categorical variable. You make use of the mode. Mode will settle the problem because mode means the one that appear most. So you make use of the mode. Mode will be used to feed the missing space. I don't think you are getting the logic I explained now.
I'm getting it, sir. I'm getting it. I'm getting it because I'm understanding English.
Okay, but you didn't get it because of the practical of it.
So again, I have okay.
The first one I explained now. Is it clear to you now? If it's not clear, let me know so that I can re-explain again.
Yes, sir. You have made me now to understand that I use median or mode when I'm using continuous variables.
Exactly.
Hello, sir.
Exactly.
When I'm using continuous variable, then
exactly.
If I'm using categorical variables,
yes,
it's more of
mode. Exactly.
That I should use.
Exactly.
It's more of mode that you should use. Now, another question I want to ask.
Okay.
Is can I ask another question?
Of course, go ahead, please.
Can I ask another question?
Go ahead, please. Of course, you are free.
Okay. The next question. Well, what's the easiest way of familiarizing myself with this course? This course we have here. What's the easiest way of getting familiarized with them? Is there any library? Is there anything that since I'm learning that I can, in my confusion, is there anything that I can ask question, or is there any way that I can be guided so that while I'm studying, like now, if it is English word, I can be able to go to dictionary to ask what is the meaning of withdrawal, and then I can find it.
Okay, good.
So,
Answer that question. The best way to get yourself right with it is for you, number one, to study more. Number two, to go and learn the Python from scratch. If you learn Python from scratch, it is the language of Python we use in machine learning. So anybody who does not have knowledge of Python from scratch will find it very difficult to understand the language when we get to machine learning or deep learning or artificial intelligence. So you need knowledge of that Python from scratch. That will help you a lot, greatly, to know more about all these brackets, this curly brackets, the normal brackets, this curly bracket you are seeing here, it has meaning in Python. This bracket you are seeing here, it has meaning in Python. This curly bracket we use to define dictionary. This bracket you are seeing here is for, this one is for list. We have one for list, we have one for tuple. This one is for tuple. This one is for, this curly one means dictionary. And they also, if you look at this bracket now, this one I'm typing here now, this one is used for list.
Yeah.
And all of them have meaning. They have meaning in Python, in Python code. They have meaning. So it is when you go to learn it from scratch, you now understand this higher level coding.
It's okay.
Am I clear? Okay. Another question, please.
Yeah, communicating.
Yeah. Okay. That's the easiest way you can get. Number one is get familiar yourself with this coding, and also go and learn that coding from scratch. That will help you a lot. When we speak any language, there was a time, for example, in our language, our is also a language. So, for example, there was a time I was taking some students in my former university, and I was taking them our language. The vice chancellor of the university was passing by my corridor, and that time I had a student that I feel wrong mad, because that mad, M-A-D, means me absolute deviation in R. But the moment the vice chancellor heard that language, that mad, he boggled into my lecture room and asked me, "Hi, hello, why are you asking them to run mad? Is that what you have to teach them?" I said, "Yes." I said, "What I'm teaching them is not English language. But to you hear that word, I feel run mad, you hear it as English language. But my communication to them is not English, it's our language." And I had the students, I feel run mad, they all say yes. And the moment they said that, I asked them, "What have you done?" They said they are run mad. I asked them again, "What have you done?" They said they are run mad. And I asked them, "What's the meaning of mad?" They told me the meaning of mad means me absolute deviation. I hope you get me now.
It's okay. Thank
you. Hope you get me now.
Absolutely.
So that's the meaning. That's the meaning. So it is quite different from, this language is different from other language. So, and we have several languages. You can always speak about your own language, your own dialect in your own country, or your own state, or your own region. In my language now, I have my own dialect, my own language, in my region, in my country. But the language that connects all of us together in terms of computing is what I'm talking about. You start from HTML, CSS, from there you move advanced to Java, JavaScript, then from there you go to Python, Haru, Juby, Julia, and so on and so forth. Apart from English language and my dialects of my country, I can speak 16 languages as I'm talking to you now, and I'm still learning more. So I think you can understand me now. So whenever I write any language to you here, this is the language that computer understands. Any question again before we close the class? Because we still have another class by 5 o'clock today. Any question again? Anybody? Any question again? If there's no question again, I think we can call it a day. If you have any question, probably when you are studying the code I sent to you and the data sets attached, you can get in touch with me through our WhatsApp group. I will attend to you, or you can get in touch with me on the Google class. You can put your question in the Google class. I will attend when I say I will attend to it. If I see it, I will attend to it. So when you are studying it, you are free to get in touch with me. If you don't get the same result I got, you have to get in touch with me, and I will attend to you. So if there's no other question on these notes, somebody say Tom, there's no other question on these notes. On behalf of the management of Osiri University, Nebraska and the US, I would like to close the class and say goodbye to everybody and God bless you until we meet again in the next meeting. Thank you.